Resistance series. It's pretty straightforward. What is resistance series? Resistor 1, then you connect resistor 2, then you connect resistor 3, and so on. You keep doing it one after each other, like you binge watching series on Netflix. So what's happening with in the circuit when resistors are connected in series? As we did before with capacitors, we can find an equivalent resistance that instead of this resistor 1, resistor 2, resistor 3, we can use just one resistor with equivalent resistance. Let's derive the formula, what it is, and try to understand it. When the current passes through one resistor and then another, the current stays the same, but potential is dropping. So if we apply Kirchhoff loop rule, let's start at this point, reference point 0, and go around the circle, loop rule, go around the loop. We would see that there is a battery, and it goes from negative to positive in this direction, so it is plus. Then we see resistor 1, and potential drops according to Ohm's law, and then resistor 2 is happening, also potential drops, resistor 2, and we're coming back to the same point, this point, so it's equal 0. So what can we say now? That EMF is equal current R1 plus R2. I just rearranged the terms. So then R1 plus R2 can be called equivalent resistance, and we would have a simple Ohm's law, where voltage is equal current multiplied by equivalent resistance, or voltage that is also EMF. So now let's go back to this formula from a picture. Equivalent resistance for resistors in series, it's just sum of resistor 1 plus resistor 2 plus resistor 3. We can connect any number of resistors in series, and equivalent resistance will be just sum of every single resistance. An equivalent resistor means that arrangement of resistors can be replaced by the equivalent resistance with no change in the current in the rest of the circuit. Now, we also can have batteries connected in series. Remember when you're buying a toy or putting batteries in the remote control, you can put more than one battery. So what's happening then with the voltage? If the battery is connected in series, battery number 1, battery number 2, connected through the wires this way, and then we have resistance. So we can apply the same Kirchhoff loop rule. Start at this point, 0. We would have first we have battery 1, then we have battery 2, and then we have minus current resistance is equal 0. We can rewrite it as Ohm's law, EMF 1 plus EMF 2 is equal equivalent EMF is equal IR. So if the battery connected in series with positive next to negative terminal, the combination of two batteries in series is equivalent to a single battery with EMF of EMF 1 plus EMF 2 plus EMF 3. Important thing here that they are connected. One important part here to remember that the battery is connected positive terminal next to negative terminal. So it's kind of one battery, then another battery, then third battery, and so on. Not if we are connecting batteries this way, we have to do something different. Resistors in parallel. We can also apply Kirchhoff loop rule here when we have two resistors connected in parallel. How we go about that? First, we need to define two different loops. because we have two resistors, we're going to have two different loops. So let's look at the first loop. We're going around pass 1, so starting at the battery, then through resistor 1, and then going back to the battery. Over here we have current I3 that goes this way. We decide that current will go this way, I1, and we're going back to current I3 that's going this way, and around the loop we're going in this way. We have to also find the second pass, and the second pass is going to go through resistor 2. And when we go around the loop, it's like we don't even see resistor 1. So we have current I2, current I3 here, and battery over here. So we're ready now to talk about Kirchhoff junction rule. It's pretty straightforward. It's very simple. The point where the currents are connected are called junction or nodes. That's what it is. Current, and then there is an intersection, and it goes, say, this way. Current I1, current I2, current I3. Electric charge cannot be created or destroyed, so the amount of current entering a junction might be equal to the current leaving it. So how much current came in a junction, the same amount is leaving out the junction. So this is called Kirchhoff junction rule. Pretty much it's I1 is equal I2 plus I3 at every junction. If we have more, if we have I4 in this junction, say we have a big intersection, so we can also add I4 here, and so on. Both Kirchhoff rules may be needed to solve a circuit. Any starting point can be used to make a complete loop around the circuit. Let's apply Kirchhoff law for the first circuit on 2 slides ago. And just to remind you, we had the battery, we had resistor R1, and it went back to the battery, and we also had a second resistor connected here, but we're not worrying about it because this is not a part of our loop. And if we apply Kirchhoff law, we would go through battery, so it's plus EMF, then we see the resistance, so it's minus I1 R1. So this is the first equation. The second equation would be for path 2, also Kirchhoff loop rule number 1. We would look now at this circuit, EMF, then it goes through resistor 2 and the current 2 over here, and then it goes back to the battery. We also had here R1 connected, but we don't care about it because it's not a part of our loop. Loop cannot have any junctions. So we would have EMF minus current 2 times resistor 2, and it's equal to 0 because we went over the loop once. And to complete the problem, we need to have a third equation that is Kirchhoff junction rule, that is I3 is equal I1 plus I2. What do we do about that? From equation 1, this step equation, we can write that current 1 is equal EMF over resistance 1. From equation 2, we can write that current 2 is equal EMF over R2. So we would plug it into our equation, and we're almost there. So we know that I3 is equal EMF times 1 over R1 plus 1 over R2. So obviously we can now state that we can replace this expression with equivalent resistance, and we will have voltage divided by 1 over R equivalent, and here just different color, 1 over R equivalent is actually 1 over R1 plus 1 over R2. So when resistors connected in parallel, we have to add its reciprocal and then take another reciprocal to find equivalent resistance. So for resistors in parallel, resistors equivalent, another way to write it is 1 over R1 plus 1 over R2 plus 1 over R3 plus and so on, depending how many resistors are in parallel in this part of a circuit. To finish this part of the lecture, we'll summarize Kirchhoff rules. Kirchhoff loop rule. The total change in the electric potential around any closed circuit path must be zero. Okay, so it's connect with potential drop. Kirchhoff junction rule is the current entering a circuit junction must be equal to the current leaving the junction. So I1 is equal I2 plus I3. Whatever comes in has to come out. These are actually application of fundamental laws of physics. So loop rule, guess what? It's just conservation of energy. Junction rule is just conservation of charge, or you can say conservation of matter. The charge cannot be destroyed or created, and conservation of energy, energy is not destroyed or created, just going from one type to another. In our case, from electrical energy to the heat. This rule applies to all types of circuits involving all types of circuit elements. So it works for every circuit, and those two rules you need to solve pretty much any circuit.